Hello, my name is Felix Kretschmer and I'm group leader for software and engineering methods at the Institute for Control Engineering at the University of Stuttgart. Today I will give you an overview on the VDMA OPC UA Weighing Technology Initiative and the actual working we are undergoing in there. Compared to the presentation of my colleague Dirk Bösel, I'll give you a few on the modeling side and the current draft of our work. Let's start with a short agenda. Beginning with the motivation and the actual knowledge transfer we are undergoing, I will show you the function of the ISW. Afterwards, we will go through the UML-derived approach for companion specification development, and we will end with a short conclusion. Regarding OPC UA activities worldwide, you often see a needed knowledge transfer, a knowledge gain in two domains. Right here, we are talking about the weighing manufacturers on the one side and the OPC UA experts on the other side. If you have these two domains, the first one actually has a large and a lot varied knowledge of weighing scales, weighing systems, everything undergoing the measurement of weight. On our side, you have the OPC UA experts. We actually do not know a lot about weighing systems, not everything besides the everyday use of a scale. Especially important for OPC UA companion standards, you need the possibilities and the functionality of OPC UA. You need to know about information modeling. You need to know about pragmatic versus technical possible differences. You need to have some kind of experience in there. And that's actually where we are experts in. So therefore, we are gaining knowledge regarding everything on weighing systems and try to give our expertise to the weighing manufacturers so they gain knowledge regarding OPC UA. Regarding this working group, we have the VDMA that has actually driven these activities. So regarding the entire working group, we have the VDMA, we have the weighing manufacturers, we have us, and we have the joint members of the OPC Foundation, which are able to join the working group. The VDMA drives this approach, so we are actually doing everything regarding the working group itself, regarding the preparation, regarding the moderation, regarding the workshop follow-up. And the VDMA tries to gain or try to drive this exchange between knowledge from weighing manufacturers and us, tries to see that there is one standard over all weighing manufacturers. But let's get more into detail regarding the companion specification itself. Companion specifications undergo some kind of UML-derived approach. That's actually our experience. If you regard other working groups at the VDMA, working groups at the OPC Foundation, the approach is always kind of the same. You try to have different viewpoints, you try to get all these different viewpoints from different manufacturers and get one standardized model at the end. For this result, you need to undergo a couple of steps in between, and the UML gives you the possibilities to undergo roles, use cases and activities and get more into detail of the domain you are actually looking at. Right here we have the step-by-step approach, beginning with roles that are actually interacting with the weighing system. Regarding use cases, so activities, these roles are actually interacting with the weighing system, and the activity itself. So you need to have a look at the activity. Regarding roles at a weighing system, we have input devices, we have condition monitoring systems, we have MES systems. We have a lot of other systems that are interacting or exchanging data with the weighing system. Identifying the relevant roles and the possible information exchange is one of the major tasks each manufacturer with us has to undergo. So afterwards, you have a long list of roles with similar communication interfaces and so on. You try to cluster. So you have one role, example, the input device, and within this role you have different input devices as an RFID reader, a keyboard, etc. Regarding the next step, you try to identify the roles that are interacting with the weighing system and what they are actually doing in there. So let's regard our use case, select the product right here on the right side. The MES system as well as the input device are able to select the product. The MES system can give this in an automation area as a preset, as the product that is going through the weighing system right now. The input device has the possibility to select the product to identify what is actually being measured at this very moment. Assigning these roles to activities is therefore pretty important to create one use case to see where is the line, where is an interconnection between a role and an activity and where is not. So the holistic approach requires the different manufacturers to get all this information, requires as well different experts within one company, because on the one hand side you have the experts regarding communication, regarding interfaces, and you have the other experts regarding the process itself. So the second one knows exactly what is happening down there, whereas the first one knows what kind of information needs to be exchanged. And you need both of them to get all the information needed for an OPC UA companion specification. Regarding our working methods, we are actually consolidating these results. So each weighing manufacturer has to ask for information at the different experts within his company. All the results are sent to us and we consolidate on the one side the roles from each manufacturer and on the other side the use cases. What we get as a result and what we get to the next working group meeting and discuss there is the use case description, because it needs a detailed information, a detailed definition of each use case, so everyone has the same understanding of one use case, as well as a use case diagram where all the roles are defined and visualized what they are actually interacting with. A use case diagram like this, or especially the one we developed right here, looks like this. And as you can see, this is quite of a large and complex system. So to identify where you actually want to start, you need to have some kind of priorities. And that's one of the major tasks we did in the working group meeting. We discussed which of the use cases are more important than other ones. So we have some kind of order where we can start to work at, especially regarding the time we have. Let's get back to the use cases. So if you look into detail, if you look at the use case itself, you need to see what is happening in there. And for this, UML gives you the possibility to visualize it in an activity diagram. You define all processes within one activity. You give the different steps, you have the control flow between the steps, and you try to visualize the control flow within this activity from the start to the end node. Regarding this, you need to identify external information sources, because within one activity you might have an external database that gives you additional information. You might have some other input devices as the keyboard, for example, that gives you another information as well. And all of these steps you undergo, you have to identify and you have to look which manufacturer has which step. There might be alternative control flows as well. So not each manufacturer is actually going each possible way. A weighing system may even skip a step just to get to the end node because it's not necessary at this use case or at this application. Identifying all of this information is quite the important part to get a standard and to get an OPC UA companion specification with all necessary data. And data is actually the important part, because if you identify all activity diagrams, they might be a little bit different at each weighing manufacturer. And what we did right here, we had a working group meeting where each of these activity diagrams for same use cases were presented by each manufacturer. This had the possibility to discuss the consolidated result. You had to identify all the differences, you had to identify all the similarities, and you even had to discuss the possibilities for one standard, because at a certain point you need to decide if you do it the one or the other way. Right in this meeting, we had the possibility to collect all the parameters as well. So if you regard an activity and if you regard each step at the activity, there are different parameters that are actually used. There are different parameters that are actually processed or the scale operates by. Collect all these parameters, lead us to differentiating different weighing system types. So you don't only have one weighing system, you need to have different types to identify all different use cases. We had a detailed capturing of use data and information, and therefore we could develop a first draft of the structure. I want to give you an overview right now. Right here you can see a companion specification similar visualization of our scale type, and right at the top you can see the scale type just as a generic scale type, And to the right, we use different possibilities and even try to derive from existing companion specifications and standards. So the most important part at standardization is not to do everything over and over again, but try to use companion specifications and definitions that are already available. One thing we are doing right here is we are deriving from the device integration at OPC UA. If we go to the bottom, you see that there are production presets and production results. Because if you regard a manufacturing execution system, there are different presets that are actually needed by the scale to fulfill the process, and results that are given back. So right here we try to have steps for jobs, for different tasks, and for products itself, and try to derive into each category. Regarding the different weighing system types, we identified different types that are used by weighing manufacturers, by clients today. And right here, I just want to go through the different possible types we identified. And for each type, we tried to cluster it, tried to categorize it, and see what information is needed. So each scale has a different subset of variables, a different subset of methods, and even a different subset of alarms and conditions, all derived by the generic scale type. So the generic scale type has the collection of all data that applies to all scales. Regarding the conclusion, I actually want to start with the question of the scope of our OPC UA interface. The first focus was on MES systems. Now, over the discussions and over the working group meetings, we identified that there are different views, that there are different applications and different use cases. And after a lot of discussions, we actually saw that we don't want to focus only on MES systems. The result was to have a generic interface which focuses on vertical connections. So if you see the automation pyramid on the right side, you see that we start at the I/O or the PLC system level, and from there we want to go up to SCADA, MES or ERP systems. Give information up there or get the information from up there into the weighing system. Therefore, we are actually at the next steps, because I already presented you the draft and the actual working state we are in right now. So the next things will be a detailed modeling in OPC notation. So we actually try to get everything ready to start into a companion specification for OPC UA. And the first next things would be the focus on allocation of parameters. So where are actually variables, where are methods used, or where are methods more useful than variables? What are possible alarms and conditions? And each of these things need to go in a feedback loop with the weighing manufacturers. At this point, I want to thank you for your attention, and you will definitely get everything about the weighing system initiative at the VDMA website, or everything in the media and the press right on the web. Thanks.